So here we go. As long as you did the right thing, we're okay. All right. Okay, I'm tickled. We're all so excited, but we need to get started now. Cosine 285. We've done these. These are the very first ones we did here. What are you going to do with 285? Well, 270 plus 15 would be okay, except what? 15 is not special. Remember, we need 45s, 60s, and 30s. 240 plus 45. I love to use 45 like Hannah. You do not need to, but anytime I see a 5 here, I think 45. Now, I got to check on 240. Is 240 okay? Let's see. 240 would look like this. How big is the reference angle for 240 degrees? 60. This is 180. It's 60 past 180, right? So this is okay. This is a good choice. All right. What does the formula say for the cosine of an angle plus an angle? Cosine of the first, cosine of the second, minus sine first, sine second. Remember, when you're doing cosine, the signs are switched. When you do sine, they're the same. All right, so now we're going to plug in our values. And the 45s, this is the reason I love to use them. I can't get them confused. They're the same. The 45s are both root 2 over 2. Now, I'm going to finish my picture over here. This is my 240 degree angle, so across from the 60 is root 3. So it looks like that. But the 1's negative and the root 3 is negative. I'm in quadrant 3, so they're both negative. All right, cosine. Negative 1 over 2. Sine. There we go. So once again, negative root 2 plus root 6 over 4.
Why'd you switch to a minus sign in the middle?
It's the formula. Cosine, cosine, minus sine, sine. It's the formula for the cosine when you add. Okay?
Every time you have a 45 degree angle, is that going to be your answer?
You're almost always, you're going to end up with, if you're doing sine and cosine, not tangent, but if you're doing sine and cosine, you're almost always going to end up with some combination of root 2, root 6 over 4. I don't know what the signs are going to be, but you're always going to end up with that because you're always using these same numbers.
Okay.
All right, here we go. Now this is new. This is brand new. Oh, by the way, I'm in my packet. Sorry, I didn't tell you that. I'm on the second sheet of the packet. I'm looking through the second sheet of the packet. So this is number 2. And this is brand new. We haven't done this before, but you have your old sheet out. So let's write down the formula for the tangent of 2x. Now, where are you going to look for it? It's a 2x. So which category is it in? Double angle. So what's the formula for the tangent of 2x? 2 tan over 1 minus tan squared. That's my formula for the tangent of 2x. That is easily derivable, but we're not going to derive it. We're just going to use it. All right, so there's the formula I'm going to use. Now, let's look at the given. Any idea what I might do to get this ball rolling here? It's in quadrant 3, so I'm going to draw a picture. I'm in quadrant 3. Does everybody see that, 180 to 270? This is 180. This is 270. What do I know about my triangle?
-4, 5, yeah, hypotenuse.
5 is hypotenuse.
-4 is the
Opposite side.
means the other one's -3.
And this one would be -3 by the Pythagorean theorem, and negative because it's in quadrant 3. So what is the tangent of this angle? What's the tangent?
4/3.
4/3. So I'm simply going to take 4/3 and plug it into my formula. 2 times the tangent, which is 4/3, over 1 minus the tangent squared, which would be 16/9. So I have 8/3, 2 times 4/3, that's the formula, over 1 minus 16/9. Now, you need to clean that up, and you can do it any way you want. So you can do this subtraction, and then invert and multiply. I'm going to times everything by 9. That's how I do it. You do not have to do it that way. But somehow, you have to fix it. So that's going to give me a 24 over a 9 minus 16, or -24/7. That's my answer. Now that's the first time you've ever done a double angle tangent. Did everybody follow all the steps there? First thing we did was figure out what formula we were going to use. And we drew a picture of the given. And we took the numbers from the picture and plugged them into the formula, and then we just had to do the work. Not too bad. All right, let's look at the next one. Oh, it's another review problem. What are we going to do with the cosine of 270 minus x?
Solve for x.
Solve for x. I'm not sure. This isn't even an equation, so I can only solve for x. This is a cosine, and that's a subtraction. What do we do when we have a cosine and a subtraction? Cosine, cosine, plus sine, sine. Whenever you have an add or subtract, you're going to use your identity, your formula. Whenever you have a double angle, you're going to use your formula. Okay, cosine x is cosine x. You're not going to be able to do anything with that, nor are you going to be able to do anything with sine x. It just is. But what about 270, cosine 270? Well, I can never remember, so I have to draw a picture of it. Here it is. And that's the point 0, -1. So you're right, cosine is 0, and sine is -1. So this just becomes 0, that's gone. And we are left with negative sine x. So your job was to simplify that, and it boils down to just negative sine. You all right with that? Now the next one is another new one. It's just like this one, except what formula are we going to use? Now we're going to need a half angle formula. Okay, so let's proceed the same way we did a minute ago. Let's figure out what formula we're going to use and write it down. So what am I finding? Cosine x over 2. Okay, what's the formula for the cosine of x over 2? Plus or minus the square root of 1 plus cosine all over 2. You're just copying that right off your gold sheet because you've never seen these before. Today's the first day. Now, what did we do? The problem I just erased, the tangent problem. First, we wrote our formula down. Then, what did we do? What did we do next? We drew a picture of the given. So, yes, Riley says it's in the 4th quadrant. Does that make sense to everybody? Between 270 and 360. Remember, this is 180, this is 270, this is 360, right? Because this is 90. And the sign is negative 5/13. So 13 here, negative 5 here.
12.
And Pythagorean theorem, this would be a 12, positive or negative? Positive. And now we're just going to figure out what that is, right? Plug it in. So we're going to have to simplify and clean it up. We're just going to plug it in. So we got plus or minus 1 plus what? 12 over 13 over 2. Everybody okay? All right, now, again, you are going to simplify this. You are juniors and seniors in high school. Do it however you want. I'm going to times everything by 13, just because that's easiest for me. So I will end up with 13 plus 12 over 26. Which is the square root of 25/26, which is 5 over root 26, if I take the square root of the top and the bottom. Which is 5 root 26 over 26, when I rationalize. You are not quite done. Is everybody with me to this point before I do the next step? Okay, so just like before, we figured out what formula we were going to use. We drew a picture of the given, and then we just took the numbers from the picture and plugged them into the formula. Everything else is just arithmetic, making it look good. Guess what you have to decide now? Do you want the plus or the minus? You have to pick one. Now, here's how you pick. It's really pretty easy. You were told that these were the boundaries for x. The question, though, you're trying to answer is, what about half of x? I'm dealing with half of x. So if we come up here and say, okay, these are the boundaries for whole x, then these would be the boundaries for half of x. Does that make sense? So this would be 135, and this would be 180. Which quadrant, then, is half of x in? Whole x was in quadrant 4. But where is half of x? These are its boundaries now, so which quadrant is it in? 2. So this angle is in quadrant 2. The angle you are looking for is in quadrant 2. You are doing the cosine. Think about angles in quadrant 2. What can you tell me about their cosine? It's negative. So So this time we're going to pick the negative root. Because whole x was in quadrant 4. So half of x ended up in quadrant 2. And in quadrant 2, the cosine is negative. Because cosine is x, and x is negative in quadrant 2. Whew, that's a biggie. All right, there's one more I want to do with you, but this one's in your book. It's a homework problem. I'll just do the first one, the first homework problem. Okay, this is your first homework problem. The homework problems are mostly like this. Not very many of them. All right, so here we go. We are going to solve this equation. Now, the first thing I want you to notice is, on this side of the equation, you have a 2x, and on this side, you have a plain x. Whenever you see a 2x, I want you to do your formula. Okay? So look on your sheet. What is the formula for the sine of 2x? 2 sine x cosine x. So that's step 1. In all of these problems, kids, I want you to take your 2x, all these equations that you're doing, I want you to take your 2x and plug in whatever the formula is. Now, I know what you're tempted to do. You're tempted maybe to divide by 2 sine. You cannot. Now you can divide by 2. There's nothing wrong with dividing by a number. That is perfectly okay. But you cannot divide by a variable because it might be 0. So even though that would make things so much easier, and I wish we could do it, we can't. What we're going to do instead is subtract. We're going to get our equation equal to 0. Now that's a common theme for us. We've often gotten our equations equal to 0. Once I do that, everybody see I just subtracted this over. What can I do now? Pull a sign out. So I'm going to pull a factor out of sine, and what will that leave me with? Cosine x minus 1. Now I'm going to remember what I always did in a regular algebra problem. When I factored, you don't write this down, it'll just confuse you later. But when you factored, what was the next step after you got it factored? What did you do next? Set them equal to 0. So we're going to take sine x equals 0 and cosine minus 1 equals 0. Okay, now we gotta think about this. That says sine is 0. This says cosine equals 1. All right, so I'm going to draw a picture here. And I'm going to go all the way around the circle. And I'm going to ask you to tell me where on this circle does the sine equal 0?
316, 180.
Right here. Anywhere else? Is that the only place? Right here. So the answers to this piece of the equation are x equals 0 or 180. Would you agree with that? right, so then you come over to this side. This one. Look around the same circle. Where is it that the cosine is 1? Okay, now, I already have that answer written down, so I don't need to write it again. If it were a different answer, I'd write it down and I'd have 3 answers. But that is a duplicate. That happens at 0, so I don't need to write it down. Does it happen anywhere else? Is there any other place the cosine is 1? Nope, that's it. That's the only place the cosine is 1. Well, we'll talk about that in a minute. So my answers are 0 and 180. Except, look at the directions. What do these directions mean? I should be answering in radians. So 0, 0, instead of 180, I will say pi. I don't say 360 because it's not included. Okay, your homework for tonight. Listen carefully. Your homework for tonight. 5 to 11i. And I just did 5. 23 and 31. And this is 5.4. And that was number 5 that I just did. And I will see you all in a couple of weeks. God bless you. I love you guys too. Yes. The only way I would be here is if my admission, I go to the hospital tomorrow, and if they push it back to the afternoon, I'll be here tomorrow morning. Thank you.